Atoms are the tiny building blocks of everything around us: your phone, your food, your water bottle, your body. Everything is made of atoms. Even though atoms are extremely small, they contain an entire world inside them. Today, we are going to decode the atom in the easiest and funniest way possible. Imagine cutting an apple into smaller and smaller pieces. Eventually, you reach a particle that cannot be divided further while still behaving like apple matter. That tiny particle is called an atom. An atom is the fundamental unit of matter. Everything in the universe is made from atoms. Now, an atom may look simple, but inside it, there is a complete action movie going on. At the center of the atom, we have the nucleus. Think of the nucleus as the VIP area of the atom because it contains the important heavy particles. Inside the nucleus, there are two particles called protons and neutrons. Protons are positively charged particles. Positive means they carry a plus charge. Neutrons are neutral particles. They have no charge at all. They are basically the calm friends trying to stop the fight between positive and negative particles. Outside the nucleus, electrons move around very quickly. Electrons are negatively charged particles. They are so tiny and fast that scientists cannot tell their exact position all the time. It is like trying to click a clear photo of a hyperactive kid running around the classroom. Instead of fixed paths, electrons stay in regions called electron clouds. The electron cloud is the region around the nucleus where electrons are most likely to be found. Inside this cloud, electrons occupy specific areas called atomic orbitals. Atomic orbitals are three-dimensional regions where the probability of finding electrons is highest. In simple words, orbitals are the favorite hangout spots of electrons. Now let us talk about the mass relationship between these particles. Protons and neutrons are much heavier than electrons. In fact, the mass of an electron is almost negligible compared to them. This relationship is called the proton-electron mass ratio, or PEMR. Because protons and neutrons are much heavier, they contribute almost all of the atom's mass. Electrons may be tiny, but they are extremely important. They control chemical reactions, bonding, and the properties of elements. The attraction between electrons and the nucleus determines how atoms interact with each other. So even though electrons are lightweight, they are the real drama creators of chemistry. Now comes one of the most important concepts: electronic configuration. Electronic configuration means the arrangement of electrons around the nucleus. Electrons do not randomly move anywhere they want. They stay in different energy levels or shells around the nucleus. These shells are named K, L, M, N, O, P, and Q. Each shell can hold a fixed number of electrons. The K shell can hold 2 electrons, the L shell can hold 8 electrons, the M shell can hold 18 electrons, and the N shell can hold 32 electrons. Inside these shells, electrons occupy smaller regions called sublevels. These are named S, P, D, and F orbitals. The K shell contains only the S sublevel. The L shell contains S and P sublevels. The M shell contains S, P, and D sublevels. The N shell contains S, P, D, and F sublevels. The arrangement of electrons is extremely important because it decides how an atom behaves. Atoms try to complete their outermost shell to become stable. This is why atoms form chemical bonds with other atoms. Basically, atoms are also searching for stability in life, just like students before exams. For example, sodium has 1 extra electron in its outer shell, while chlorine needs 1 electron to complete its shell. So sodium happily gives away its electron, chlorine accepts it, and together they form sodium chloride, common table salt. Chemistry is literally atoms making friendships and relationships. Understanding electronic configuration also helps scientists explain the periodic table, chemical reactions, bonding, conductivity, and many other properties of matter. So, the atom may be tiny, but it controls the entire universe around us. Inside every atom, there are protons giving positive vibes, neutrons maintaining peace, and electrons running around creating chaos. Together, these particles decide the properties and behavior of every element in existence. And that is how the tiny atom becomes the foundation of the massive universe around us.